So this is the last question in 2015, number 6. And this is our implicit differentiation problem. So the first part A, asks you to find the equation for the line tangent to the curve at negative 1, 1. Well, they give us the x and the y value, which is nice. I mean, they have to, but you don't have to go and find a y value. So what I need to do is I need to find the slope of the equation. And the way I do that is, remember, the slope of the tangent line is the derivative. So dy dx evaluated at that point, negative 1, 1, will give me the slope of the tangent line, which is 1/4. So my equation is just 1 minus 1, or y minus 1 equals 1/4 times x plus 1. Okay, that's part A. Part B says find the coordinates of all points on the curve, which the tangent line to the curve at that point is vertical. What do we mean by that? That means that the slope of the tangent line is undefined. So m is undefined. How do we get an undefined slope? If the denominator is 0. So what I do is I set that equal to 0. Okay, and then you might say to yourself, well, what the heck do I do here? They want coordinates of a point. Well, you have another equation. You have the original equation. So that's actually what you're going to do here. You're going to use and you're going to substitute this in for that. So y is negative 1. Now I plug this back into the original equation, not the derivative. So that would give me negative 1 cubed minus x times negative 1 equals 2. So x ends up being 3. So that's kind of that crucial step in that process. So when you're reviewing differential equations, remember, if they ask you, they might ask you to find a point where the tangent line is horizontal or vertical or equal to a number. That's when you're going to have to substitute. Part C wants us to find the second derivative, which is, this is the cumbersome question. So if you know you're prone to algebra mistakes, work very carefully. You only get 1 point for the final answer, and the other 3 points are for the actual work leading up to the algebra, but still, 1 point from algebra. Okay, so we want... Okay, so I'm going to start with, now I have to use the quotient rule. So the quotient rule, and remember I'm deriving implicitly, so that would be dy dx times the bottom minus the derivative of the bottom. Oop. So minus 1 times the derivative times the top, which is y, all over the bottom squared. Okay, so now I'm going to clean this up a little bit, and I have to substitute in what dy dx is in for dy dx right here and here. So that would mean that I get y over 3y squared minus x times, oh, that's going to be nice, Okay, so these will cancel, which is nice. That's the only thing that's going to cancel here. And at this point, don't worry about simplifying this. You've already gotten the points for the implicit differentiation and the substitution. Now you should just worry about plugging in. So we want -1, 1. So that means I'm going to do 1 minus 6 times 1 over 4 minus 1 times 1 over. So after using PEMDAS and all of that, you're going to get 1 over 32. And that's it.